Okay, welcome back. We are asked to find the derivative of cot x from the first principle. So, we're right. We know that first principle that the derivative of any cot as f prime x is always equal to the limit of h tends to 0 of fx plus h minus fx over h. So that's it. Differentiation from the first principle derivative. Differentiation of derivative from the first principle. So that's what we are looking at. So the first thing is that the function fx is cot x. So the next thing, like we are using this like a guide, is to get, if you look at fx plus h is that, so you see that fx plus h is now cot x plus h. Therefore the derivative we are looking for, which is f prime x, is now equal to limit of h tends to 0 of cot x plus h, that which is fx plus h, minus cot x over h. And here we know that cot is cos over sine. So cot is cosine over sine. Minus cos x over sine x all over h. So we have limiting the limit of h tends to 0 of the LCM is that, so we have h times h sine x plus h. So which is cos x plus h cos sine x sine x minus sine x plus h cos x. So we are still correct, we are progressing. So if we expand this, we have, this is from our addition formula of cosine, so we have sine, I'm writing this, I wrote this sine x first, so we'll now expand this, which is cos x cos h minus sine x sine h. So cos x plus h is this, minus cos x sine x cos h plus cos x sine h. So using addition formula here, that's what we use for both cosine. So over h sine, remember this limit, so this is the limit of h tends to 0 of everything, which is sine x sine s plus h. So if you open up this bracket, you see that this, okay, let's just open. So fine, we're still on it. That's the f prime x. So this limit of h tends to 0 of, we'll open this, if you notice this time this is sine x cos h, while this is minus x sine x cos h, so this will go. So we are left with this times this, which is minus sine squared x sine h. So this one is gone. That's this first product. They are the same. So this minus this is 0. So we have minus cos squared x sine h. H sine x plus h. So which is equal to the limit of h tends to 0 of, if you notice we have common term here, you can bring out minus sine x sine h. So we are left with sine squared x plus cos squared x. So h sine x plus h. So we now have limits of h tends to 0 of, if you remember, sine squared x plus cos squared x is 1, so we're left with minus sine h over h sine x plus h, which could be written as limit of h tends to 0 of minus of sine h over h times minus 1 over sine x plus h. So there's what we call, okay, we can know this product. So the limit of a product is h tends to 0 of sine h over h times the limit of h tends to 0 of minus 1 over sine x plus h. So that's the limit of a product. Is the same as getting the limits of the two. And from our L'Hopital's rule, this is, that's the limit of that is 1. Because whenever you get substitute and get 0 over 0, you apply L'Hopital's rule. You can check it. So the limit of this is 1. Why the limit of this times minus 1 sine x, so h is 0, so sine squared x. So finally this is minus 1 over sine squared is cosec squared, so 1 over cosec squared x. So which is the derivative of cot x. So the key point here, I need to know this special limit. We apply L'Hopital's rule. That's once you substitute and get 0 over 0 is an indeterminate form, so we differentiate up and down and substitute. So if you differentiate sine, it gives you cos. If you differentiate h, give you 1. So before you substitute now, cos 0 is 1. So that's how we got 1. So that's a very tricky question. Thank you.